repeating decimal, I want you to put the fraction part. Okay? Now that being said, let me show you how to use your calculator with that. And also, don't round it. 2.3 is not the same as 2.3 repeating. Okay? Those are not equal. While we're on this topic, on your calculators, this will help you out, especially if you aren't super comfortable with fractions. Let's say you have, we'll just do an easy one that we know, 0.75. If you go to the math menu, so right underneath the green button, if you go to the math menu, there's a triangle pointing to the word FRAC, so that converts things to a fraction. So you want 0.375 as a fraction. We all know that should be what? 3/4. So there's your fraction, 3/4. Okay? Yeah.
No, can you tell us how to go back into a column again?
Push second enter. Second enter takes you back to the previous, what you previously typed. And if you do it again, it'll take you even further back. So just push second before you press enter. Okay, Christian?
How do you get percentages on these?
Multiply by 100. Just take your number and move the decimal 2 to the right. You remember how to do it. Okay. So that can come in handy, especially when working with some fractions here. Okie dokie. Alright. So the constant rate of change, the next one is going to be a variable rate of change. And for that, I want you to think of the stock market. The stock market, does that change the same every single day? No. But on average, guess how much it goes up over the course of its lifetime per year? It's about 10%. Okay, on average. So some years are better, some years are less. So it's not a constant rate of change, it's going to be a variable rate of change. Okay. So let's write this down. Remember, the rate of change is the change in the y values divided by the change in the x values. Okay. Do you all remember the slope formula using that? You want me to go over that at all? Okay. I think that's usually something hit pretty hard in junior high. So if you have questions on it, please let me know. So here, these sort of questions, is this a constant? Let's look at the blue line. Is that a constant rate of change or a variable rate of change? Variable. Now, on average, is it increasing or decreasing? Increasing. So that should be a positive rate of change. Now, this red line will be a positive or negative rate of change. Negative. So remember, positive rates of change are things that are increasing. Negative rates of change are things that are decreasing. And you can find the average rate of change between different points by just using the points and using the slope formula. So when they give you this, you can use the slope formula. When they give you a graph, can you just count the squares and go off the squares? Okay. Be careful. So sometimes you can, sometimes you can't. So like on this one, you see how it goes up. You want to point right there. How many does it go up with 2 points? That's 3.
Oh,
Come back. So from right there to right there, how much are we going up? So what number would this be right here? That's 20. And this line is 32, so we want up 12. How much did we go over? So from here to here. So this line is 0, this line is 20. So how many did we go over? 20. So do I say 12 divided by 20 or 20 divided by 12?
12.
Okay. Change in the y's over the change in the x's. Reduce it, you get 3/5. Now, does that match the squares? If I just count the squares, I'm going up 3 and over 5, right? So that would be our rate of change. Does that match the squares there? Yeah. Now, your hint there is look at what each line is. What is each line on the x-axis? 4. What's each line on the y-axis? 4. So if your x-axis and y-axis agree with what each line is, you can just count the squares and make it easy. But you can't count the squares like on this one. If I go from here to here, here's my 2 points. You're like, oh, up 1 over 1. Slope is 1, right? Okay. How much did I go up when I went up one line? 5, right? I went from 10 to 15. How much did I go over? 1. So this slope would be 5 over 1, which is 5. Okay. Which one's steeper between these two, the 3/5 or the 5? Which one is the steeper line?
5.
5 is bigger, right? Could I make a slope of 5 look flatter, though, than a slope of 3/5? Using changing the scaling? Because on the number line, how close is 3/5 to 5? Is it really that close? No, but do these slopes look somewhat close?
Yeah.
Okay, so it all depends on what they're counting by along the x and y axis. So when you have a graph, just make sure you're tracking how much is this changing compared to how much is this changing. If they're the same, you can just count the squares. If they're not, then you need to figure out the actual difference. Okay? All right, I'll let you get back to work on that. Come up with questions, let me know. Have you completely confused now? Hopefully this is somewhat review. The idea of rate of change, I try to go into more detail about what it actually is. Rate of change is slope. I haven't used the word slope much, but it is the same. Uh-huh.
When we're finding the slope, do we put like a would it be like would it this is an example, would it be 1/14 or 15?
Leave it as an improper fraction. So you just leave it 15. When you're just finding the slope, the plain old problems like this, like 4, 5, and 6, and when they look like this, they just give you 2 points. Leave your answer as an improper fraction. So that'd be like, leave it as 9/4 instead of 2/4. Okay? So you can leave it as an improper fraction.